Extra models continuing with the previous example, it will be common to have more than one related model. This is especially the case for user models because the input model needs to be able to have a password. The output model should not have a password. The database model would probably need to have a hashed password. Danger: never store users' plaintext passwords. Extra models continuing with the previous example, it will be common to have more than one related model. This is especially the case for user models because the input model needs to be able to have a password. The output model should not have a password. The database model would probably need to have a hashed password. Danger: never store users' plaintext passwords. Always store a secure hash that you can then verify. If you don't know, you will learn what a password hash is in the security chapter's internal link target equals blank. Multiple models: here's a general idea of how the models could look like with their password fields and the places where they are used. Info in Pydantic v1, the method was called dict. It was deprecated but still supported in Pydantic v2 and renamed to model dump. The examples here use dict for compatibility with Pydantic v1, but you should use model dump instead if you can use Pydantic v2. About userin, dict Pydantics. Dict userin is a Pydantic model of class userin. Pydantic models have a dict method that returns a dict with the model's data. So, if we create a Pydantic object userin-like, and then we call, we now have a dict with the data in the variable userdict. It's a dict instead of a Pydantic model object. And if we call, we would get a Python dict with unpacking a dict. If we take a dict like userdict and pass it to a function or class with userdict, Python will unpack it. It will pass the keys and values of the userdict directly as key value arguments. So, continuing with the userdict from above, writing would result in something equivalent to, or more exactly, using userdict directly with whatever contents it might have in the future. A Pydantic model from the contents of another, as in the example above we got userdict from userin. Dict, this code, would be equivalent to, because userin, dict is a dict, and then we make Python unpack it by passing it to userindb prefixed with. So we get a Pydantic model from the data in another Pydantic model. Unpacking a dict and extra keywords, and then adding the extra keyword argument hashed password equals hashed password, like in, ends up being like. Warning: the supporting additional functions fakepassword hasher and fakesofUser are just to demo a possible flow of the data, but they of course are not providing any real security. Reduce duplication. Reducing code duplication is one of the core ideas in FastAPI. As code duplication increments the chances of bugs, security issues, code desynchronization issues when you update in one place but not in the others, etc., and these models are all sharing a lot of the data and duplicating attribute names and types. We could do better. We can declare a user base model that serves as a base for our other models. And then we can make subclasses of that model that inherit its attributes, type declarations, validation, etc. All the data conversion, validation, documentation, etc. will still work as normally. That way, we can declare just the differences between the models with plaintext password, with hashed password, and without password. Union or any of, you can declare a response to be the union of two or more types. That means that the response would be any of them. It will be defined in OpenAPI with any of. To do that, use the standard Python type hint typing. Union. Note: when defining a union, include the most specific type first, followed by the less specific type. In the example below, the more specific plain item comes before car item in union plain item, car item. Union in Python 3.1, in this example we pass union plain item, car item as the value of the argument response model. Because we are passing it as a value to an argument instead of putting it in a type annotation, we have to use union even in Python 3.1. If it was in a type annotation, we could have used the vertical bar, as. But if we put that in the assignment response model equals plain item car item, we would get an error, because Python would try to perform an invalid operation between plain item and car item instead of interpreting that as a type annotation. List of models the same way, you can declare responses of lists of objects. For that, use the standard Python typing. List or just list in Python 3.9 and above. Response with arbitrary dict, you can also declare a response using a plain arbitrary dict, declaring just the type of the keys and values without using a pydantic model. This is useful if you don't know the valid field attribute names that would be needed for a pydantic model beforehand. In this case, you can use typing, dict or just dict in Python 3.9 and above. Recap use multiple pydantic models and inherit freely for each case. You don't need to have a single data model per entity if that entity must be able to have different states. As the case with the user entity, with a state including password, password hash, and no password. Response status code the same way you can specify a response model. You can also declare the HTTP status code used for the response with the parameter status code in any of the path operations. At app, get at app, post at app, put at app, delete, etc. Notice that status code is a parameter of the decorator method get, post, etc. not of your path operation function, like all the parameters and body. The status code parameter receives a number with the HTTP status code. Info status code can alternatively also receive an int num, such as Python's HTTP status. It will return that status code in the response. Document it as such in the OpenAPI schema, and so, in the user interfaces. Note some response codes see the next section indicate that the response does not have a body. FastAPI knows this and will produce OpenAPI docs that state there is no response body. About HTTP status codes, note if you already know what HTTP status codes are, skip to the next section. In HTTP, you send a numeric status code of 3 digits as part of the response. These status codes have a name associated to recognize them, but the important part is the number. In short, 100-199 are for information. You rarely use them directly. Responses with these status codes cannot have a body. 200-299 are for successful responses. These are the ones you would use the most. 200 is the default status code, which means everything was okay. Another example would be 201, created. It is commonly used after creating a new record in the database. A special case is 204, no content. This response is used when there is no content to return to the client, and so the response must not have a body. 300-399 are for redirection. Responses with these status codes may or may not have a body, except for 304, not modified, which must not have one. 400-499 are for client error responses. These are the second type you would probably use the most. An example is 404 for a not found response. For generic errors from the client, you can just use 400. 500-599 are for server errors. You almost never use them directly. When something goes wrong at some part in your application code or server, it will automatically return one of these status codes. Tip to know more about each status code and which code is for what, check the MDN documentation about HTTP status codes. Shortcut to remember the names, let's see the previous example again. 201 is the status code for created. But you don't have to memorize what each of these codes mean. You can use the convenience variables from FastAPI, status. They are just a convenience, they hold the same number, but that way you can use the editor's autocomplete to find them. Note technical details you could also use from starlet import status. FastAPI provides the same starlet status as FastAPI, status just as a convenience for you, the developer, but it comes directly from starlet. Changing the default later, in the advanced user guide internal link target equals blank, you will see how to return a different status code than the default you are declaring here. Form data when you need to receive form fields instead of JSON, you can use form. Info to use forms, first install Python multipart. Make sure you create a virtual environment internal link target equals blank, activate it, and then install it, for example. Import form from FastAPI. Define form parameters, create form parameters the same way you would for body or query. For example, in one of the ways the OAuth2 specification can be used called password flow, it is required to send a username and password as form fields. The spec requires the fields to be exactly named username and password, and to be sent as form fields, not JSON. With form you can declare the same configurations as with body and query, path, cookie, including validation, examples, and alias e.g. username instead of username, etc. Info form is a class that inherits directly from body. Tip to declare form bodies, you need to use form explicitly, because without it the parameters would be interpreted as query parameters or body JSON parameters. About form fields, the way HTML forms sends the data to the server normally uses a special encoding for that data. It's different from JSON. FastAPI will make sure to read that data from the right place instead of JSON. Note technical details data from forms is normally encoded using the media type, application, XWWW former encoded. But when the form includes files, it is encoded as multi-part form data. You'll read about handling files in the next chapter. If you want to read more about these encodings and form fields, head to the MDN web docs for post. Warning, you can declare multiple form parameters in a path operation, but you can't also declare body fields that you expect to receive as JSON, as the request will have the body encoded using application XWWW former encoded instead of application JSON. This is not a limitation of FastAPI. It's part of the HTTP protocol. Recap use form to declare form data input parameters. Form models, you can use Pydantic models to declare form fields in FastAPI. Info to use forms, first install Python multipart. Make sure you create a virtual environment internal link target equals blank, activate it, and then install it, for example. Note this is supported since FastAPI version 0.1130. Nerd face pydantic models for forms, you just need to declare a pydantic model with the fields you want to receive as form fields, and then declare the parameter as form. FastAPI will extract the data for each field from the form data in the request and give you the pydantic model you defined. Check the docs, you can verify it in the docs UI at docs. Forbid extra form fields in some special use cases, probably not very common. You might want to restrict 113 multipart. Make sure you create a virtual environment internal link target equals blank, activate it, and then install it, for example. Note this is supported since FastAPI version 0.1130. Nerd face pydantic models for forms, you just need to declare a pydantic model with the fields you want to receive as form fields, and then declare the parameter as form. FastAPI will extract the data for each field from the form data in the request and give you the pydantic model you defined. Check the docs, you can verify it in the docs UI at docs. Forbid extra form fields in some special use cases, probably not very common. You might want to restrict the form fields to only those declared in the pydantic model. And forbid any extra fields. Note this is supported since FastAPI version 0.1140. Nerdface, you can use pydantic's model configuration to forbid any extra fields. If a client tries to send some extra data, they will receive an error response. For example, if the client tries to send the form fields, username, Rick password, portal gun extra, Mr. Poopabutthole, they will receive an error response telling them that the field extra is not allowed. Summary, you can use pydantic models to declare form fields in FastAPI. Smiling face with sunglasses. Request files, you can define files to be uploaded by the client using file. Info to receive uploaded files, first install Python multipart. Make sure you create a virtual environment internal link target equals blank, activate it, and then install it, for example. This is because uploaded files are sent as form data. Import file, and upload file from FastAPI. Define file parameters, create file parameters the same way you would for body or form. Info file is a class that inherits directly from form. But remember that when you import query, path, file, and others from FastAPI, those are actually functions that return special classes. Tip: to declare file bodies, you need to use file because otherwise the parameters would be interpreted as query parameters or body JSON parameters. The files will be uploaded as form data. If you declare the type of your path operation function parameter as bytes, FastAPI will read the file for you and you will receive the contents as bytes. Keep in mind that this means that the whole contents will be stored in memory. This will work well for small files, but there are several cases in which you might benefit from using upload file. File parameters with upload file define a file parameter with a type of upload file. Using upload file has several advantages over bytes. You don't have to use file in the default value of the parameter. It uses a spooled file, a file stored in memory up to a maximum size limit, and after passing this limit, it will be stored in disk. This means that it will work well for large files like images, videos, large binaries, etc. without consuming all the memory. You can get metadata from the uploaded file. It has a file-like async interface. It exposes an actual Python spooled temporary file object that you can pass directly to other libraries that expect a file-like object. Upload file has the following attributes: file name, a SDR with the original file name that was uploaded, e.g. image, JPG. Content type, a SDR with the content type MIME type media type, e.g. image JPEG. File, a spooled temporary file, a file-like object. This is the actual Python file object that you can pass directly to other functions or libraries that expect a file-like object. Upload file has the following async methods. They all call the corresponding file methods underneath using the internal spooled temporary file. Write data writes data SDR or bytes to the file. Read size reads size int bytes characters of the file. Seek offset goes to the byte position offset int in the file. E.g., await myfile, seek 0 would go to the start of the file. This is especially useful if you run await myfile, read once and then need to read the contents again. Close closes the file. As all these methods are async methods, you need to await them. For example, inside of an async path operation function, you can get the contents with. If you are inside of a normal def path operation function, you can access the upload file directly. For example, note async technical details. When you use the async methods, FastAPI runs the file methods in a thread pool and awaits for them. Note starlet technical details. FastAPI's upload file inherits directly from starlet's upload file, but adds some necessary parts to make it compatible with Pydantic and the other parts of FastAPI. What is form data? The way HTML forms sends the data to the server normally uses a special encoding for that data. It's different from JSON. FastAPI will make sure to read that data from the right place instead of JSON. Note technical details data from forms is normally encoded using the media type application XWWW former encoded when it doesn't include files. But when the form includes files, it is encoded as multi-part form data. If you use file, FastAPI will know it has to get the files from the correct part of the body. If you want to read more about these encodings and form fields, head to the MDN web docs for post. Warning: you can declare multiple file and form parameters in a path operation, but you can't also declare body fields that you expect to receive as JSON, as the request will have the body encoded using multi-part form data instead of application JSON. This is not a limitation of FastAPI. It's part of the HTTP protocol. Optional file upload: you can make a file optional by using standard type annotations and setting a default value of none. Upload file with additional metadata: you can also use file with upload file, for example, to set additional metadata. Multiple file uploads: it's possible to upload several files at the same time. They would be associated to the same form field sent using form data. To use that, declare a list of bytes or upload file. You will receive, as declared, a list of bytes or upload files. Note technical details: you could also use from starlet. Responses: import HTML response. FastAPI provides the same starlet responses as FastAPI. Responses just as a convenience for you, the developer. But most of the available responses come directly from starlet. Multiple file uploads with additional metadata. And the same way as before, you can use file to set additional parameters, even for upload file. Recap: use file, bytes, and upload file to declare files to be uploaded in the request, sent as form data. Request forms and files, you can define files and form fields at the same time using file and form. Info to receive uploaded files and/or form data. First install Python multipart. Make sure you create a virtual environment internal link target equals blank, activate it, and then install it, for example. Import file and form, define file and form parameters, create file and form parameters the same way you would for body or query. The files and form fields will be uploaded as form data, and you will receive the files and form fields. And you can declare some of the files as bytes and some as upload file. Warning, you can declare multiple file and form parameters in a path operation, but you can't also declare body fields that you expect to receive as JSON. Request forms and files, you can define files and form fields at the same time using file and form. Info to receive uploaded files and/or form data. First install Python multipart. Make sure you create a virtual environment internal link target equals blank, activate it, and then install it, for example. Import file and form, define file and form parameters, create file and form parameters the same way you would for body or query. The files and form fields will be uploaded as form data, and you will receive the files and form fields. And you can declare some of the files as bytes and some as upload file. Warning, you can declare multiple file and form parameters in a path operation, but you can't also declare body fields that you expect to receive as JSON, as the request will have the body encoded using multipart form data instead of application JSON. This is not a limitation of FastAPI. It's part of the HTTP protocol. Recap, use file and form together when you need to receive data and files in the same request. Handling errors, there are many situations in which you need to notify an error to a client. In these cases, you would normally return an HTTP status code. Use HTTP exception to return HTTP responses with. This also means that if you are inside a utility function, in this example, when the client requests an item by an ID that doesn't exist, example.com items bar a non-existent itemid bar. Add custom headers. There are some situations in where it's useful to be. Let's say you have a custom exception unicorn exception that you or a library so you will receive a clean error with an HTTP status code of 418. Override the default exception handler's FastAPI has some default To override it, import the request validation error and use. Request validation error is a subclass of Pydantic's validation error. It should be this way because if you have a Pydantic validation error in your response or any, for example, you could want to return a plain text response instead of JSON for these errors. You could use it while developing your app to log the body and debug it. The only difference is that this way, if any part of Starlet's internal code or a Starlet extension, in this example, you can use the exception and then just reuse the default exception handlers. Handling errors, there are many situations in which you need to notify an error to a client that is using your API. This client could be a browser with a front end, a code from someone else, an IoT device, etc. You could need to tell the client that the client doesn't have enough privileges for that operation. The client doesn't have access to that resource. The item the client was trying to access doesn't exist, etc. Handling errors, there are many situations in which you need to notify an error to a client that is using your API. This client could be a browser with a front end, a code from someone else, an IoT device, etc. You could need to tell the client that the client doesn't have enough privileges for that operation. The client doesn't have access to that resource. The item the client was trying to access doesn't exist, and converted to JSON. Add custom headers. There are some situations in where it's useful to be able to add custom headers to the HTTP error. For example, for some types of security. You probably won't need to use it directly in your code, but in case you needed it for an advanced scenario, you can add custom headers. Install custom exception handlers. You can add custom exception handlers with the same exception utilities from Starlet. Let's say you have a custom exception unicorn exception that you or a library you use might raise, and you want to handle this exception globally with FastAPI. You could add a custom exception handler with an app, exception handler. Here, if you request unicorns YOLO, the path operation will raise a unicorn exception, but it will be handled by the unicorn exception handler. So you will receive a clean error with an HTTP status code of 418 and a JSON content of. Note technical details you could also use from Starlet. Requests import request and from Starlet. Responses import JSON response. FastAPI provides the same Starlet. Responses as FastAPI. Responses just as a convenience for you, the developer. But most of the available responses come directly from Starlet. The same with request. Path operation configuration, there are several parameters that you can pass to your path operation decorator to configure it. Warning, notice that these parameters are passed directly to the path operation decorator, not to your path operation function. Response status code, you can define the HTTP status code to be used in the response of your path operation. You can pass directly the int code, like 404. But if you don't remember what each number code is for, you can use the shortcut constants in status. That status code will be used in the response and will be added to the FastAPI schema. Note technical details you could also use from Starlet import status. FastAPI provides the same Starlet status as FastAPI, status just as a convenience for you, the developer, but it comes directly from Starlet. Tags, you can add tags to your path operation, pass the parameter tags with a list of SDR, commonly just one SDR. They will be added to the FastAPI schema and used by the automatic documentation interfaces. Tags with enums, if you have a big application, you might end up accumulating several tags, and you would want to make sure you always use the same tag for related path operations. In these cases, it could make sense to store the tags in an enum. FastAPI supports that the same way as with plain strings. Summary and description, you can add a summary and description. Description from docstring, as descriptions tend to be long and cover multiple lines, you can declare the path operation description in the function docstring, and FastAPI will read it from there. You can write markdown in the docstring. It will be interpreted and displayed correctly, taking into account docstring indentation. It will be used in the interactive docs. Response description, you can specify the response description with the parameter response description. Info, notice that response description refers specifically to the response. The description refers to the path operation in general. Check FastAPI specifies that each path operation requires a response description. So, if you don't provide one, FastAPI will automatically generate one of successful response. Deprecate a path operation, if you need to mark a path operation as deprecated, but without removing it, pass the parameter deprecated. It will be clearly marked as deprecated in the interactive docs. Check how deprecated and non-deprecated path operations look like. Recap, you can configure and add metadata for your path operations easily by passing parameters to the path operation decorators. path operation configuration. JSON compatible encoder. There are some cases where you might need to convert a data type like a pedantic model to something compatible with JSON like a dict, list, etc. For example, if you need to store it in a database. For that, FastAPI provides a JSON-able encoder function. Using the JSON-able encoder, let's imagine that you have a database FakeDB that only receives JSON-compatible data. For example, it doesn't receive data time objects, as those are not compatible with JSON. So, a data time object would have to be converted to a SDR containing the data in ISO format. The same way, this database wouldn't receive a pedantic model and object with attributes, only a dict. You can use JSON-able encoder for that. It receives an object, like a pedantic model, and returns a JSON-compatible version. In this example, it would convert the pedantic model to a dict and the data time to a SDR. The result of calling it is something that can be encoded with the Python standard JSON, dumps. It doesn't return a large SDR containing the data in JSON format as a string. It returns a Python standard data structure, e.g., a dict with values and subvalues that are all compatible with JSON. Note JSON-able encoder is actually used by FastAPI internally to convert data, but it is useful in many other scenarios. body updates update replacing with put to update an item, you can use the HTTP PUT operation. You can use the JSON-able encoder to convert the input data to data that can be stored as JSON-IG with a NoSQL database. For example, converting data time to SDR. PUT is used to receive data that should replace the existing data. Warning about replacing that means that if you want to update the item bar using PUT with a body containing, because it doesn't include the already stored attribute tax. 20.2, the input model.
So we have fake database item. We have put item ID, item ID.
Model would take the default value of tax, 10.5, and the data would be saved with that new tax of 10.5. Partial updates with patch, you can also use the HTTP patch operation to partially update data. This means that you can send only the data that you want to update, leaving the rest intact. Note patch is less commonly used and known than PUT, and many teams use only PUT, even for partial updates. You are free to use them however you want. FastAPI doesn't impose any restrictions, but this guide shows you, more or less, how they are intended to be used. Using Pydantic's exclusion set parameter if you want. Receive partial updates, it's very useful to use the parameter exclusion set in Pydantic's models, model dump. Like item, model dump exclusion set equals true. Info in Pydantic v1, the method was called dict. It was deprecated but still supported in Pydantic v2 and renamed to model dump. The examples here use dict for compatibility with Pydantic v1, but you should use model dump instead if you can use Pydantic v2. That would generate a dict with only the data that was set when creating the item model, excluding default values. Then you can use this to generate a dict with only the data that was sent in the request, omitting default values. Using Pydantic's update parameter now, You can create a copy of the existing model using ModelCopy and pass the update parameter with a dict containing the data to update. Info in Pydantic v1, the method was called copy. It was deprecated but still supported in Pydantic v2 and renamed to ModelCopy. The examples here use copy for compatibility with Pydantic v1, but you should use ModelCopy instead if you can use Pydantic v2. Like StoreDite model copyUpdate equals update data. Partial updates recap in summary. To apply partial updates, you would optionally use patch instead of PUT. Retrieve the stored data. Put that data in a Pydantic model. Generate a dict without default values from the input model using excludeUnset. This way you can update only the values actually set by the user, instead of overriding values already stored with default values in your model. Create a copy of the stored model, updating its attributes with the received partial updates using the update parameter. Convert the copied model to something that can be stored in your DB, for example, using the JSON-able encoder. This is comparable to using the model dump method again, but it makes sure and converts the values to data types that can be converted to JSON, for example, data time to SDR. Save the data to your DB. Return the updated model. Tip: you can actually use this same technique with an HTTP PUT operation, but the example here uses patch because it was created for these use cases. Notice that the input model is still validated. So, if you want to receive partial updates that can omit all the attributes, you need to have a model with all the attributes marked as optional with default values or none. To distinguish from the models with all optional values for updates and models with required values for creation, you can use the ideas described in extra models internal link target equals blank.
नाही चिकन आणलेलं इंग्लिश डॉक्स
Dependencies FastAPI has a very powerful but intuitive dependency injection system. It is designed to be very simple to use and to make it very easy for any developer to integrate other components with FastAPI. What is dependency injection? Dependency injection means, in programming, that there is a way for your code in this case, your path operation functions to declare things that it requires to work in use. Dependencies. And then, that system in this case, FastAPI, will take care of doing whatever is needed to provide your code with those needed dependencies, inject the dependencies. This is very useful when you need to have shared logic, the same code logic again and again. Share database connections, enforce security, authentication, role requirements, etc., and many other things, all these while minimizing code repetition. First steps, let's see a very simple example. It will be so simple that it is not very useful for now, but this way we can focus on how the dependency injection system works. Create a dependency, or dependable. Let's first focus on the dependency. It is just a function that can take all the same parameters that a path operation function can take. That's it. 2 lines. And it has the same shape and structure that all your path operation functions have. You can think of it as a path operation function without the decorator, without the @app_get_some_path. And it can return anything you want. In this case, this dependency expects an optional query parameter q that is a str, an optional query parameter skip that is an int and by default is 0, an optional query parameter limit that is an int and by default is 100, and then it just returns a dict containing those values. Info FastAPI added support for annotated and started recommending it in version 0.95.0. If you have an older version, you would get errors when trying to use annotated. Make sure you upgrade the FastAPI version internal link target equals blank to at least 0.95.1 before using annotated. Import depends declare the dependency. In the dependent, the same way you use body, query, etc. with your path operation function parameters, use depends with a new parameter. Although you use depends in the parameters of your function the same way you use body, query, etc., depends works a bit differently. You only give depends a single parameter. This parameter must be something like a function. You don't call it directly, don't add the parenthesis at the end, you just pass it as a parameter to depends. And that function takes parameters in the same way that path operation functions do. Tip, you'll see what other things, apart from functions, can be used as dependencies in the next chapter. Whenever a new request arrives, FastAPI will take care of calling your dependency, dependable function with the correct parameters. Get the result from your function. Assign that result to the parameter in your path operation function. This way you write shared code once and FastAPI takes care of calling it for your path operations. Check notice that you don't have to create a special class and pass it somewhere to FastAPI to register it or anything similar. You just pass it to depends and FastAPI knows how to do the rest. Share annotated dependencies in the examples above, you see that there's a tiny bit of code duplication. When you need to use the common parameters dependency, you have to write the whole parameter with the type annotation and depends. But because we are using annotated, we can store that annotated value in a variable and use it in multiple places. Tip, this is just standard Python. It's called a type alias. It's actually not specific to FastAPI. But because FastAPI is based on the Python standards, including annotated, you can use this trick in your code. The dependencies will keep working as expected, and the best part is that the type information will be preserved, which means that your editor will be able to keep providing you with auto-completion, inline errors, etc. The same for other tools like MyPy. This will be especially useful when you use it in a large code base where you use the same dependencies over and over again in many path operations. To async or not to async as dependencies will also be called by FastAPI the same as your path operation functions. The same rules apply while defining your functions. You can use async def or normal def. And you can declare dependencies with async def inside of normal def path operation functions, or def dependencies inside of async def path operation functions, etc. It doesn't matter. FastAPI will know what to do. Note if you don't know, check the async. In a hurry, internal link target equals blank section about async and await in the docs. Integrated with OpenAPI, all the request declarations, validations, and requirements of your dependencies and subdependencies will be integrated in the same OpenAPI schema. So the interactive docs will have all the information from these dependencies too. Simple usage, if you look at it, path operation functions are declared to be used whenever a path and operation matches, and then FastAPI takes care of calling the function with the correct parameters, extracting the data from the request. Actually, all or most of the web frameworks work in the same way. You never call those functions directly. They are called by your framework, in this case, FastAPI. With the dependency injection system, you can also tell FastAPI that your path operation function also depends on something else that should be executed before your path operation function. And FastAPI will take care of executing it and injecting the results. Other common terms for this same idea of dependency injection. R. Resources, providers, services, injectables, components, FastAPI plugins, integrations, and plugins can be built using the dependency injection system. But in fact, there is actually no need to create plugins, as by using dependencies, it's possible to declare an infinite number of integrations and interactions that become available to your path operation functions. And dependencies can be created in a very simple and intuitive way that allows you to just import the Python packages you need and integrate them with your API functions in a couple of lines of code, literally. You will see examples of this in the next chapters about relational and NoSQL databases, security, etc. FastAPI compatibility. The simplicity of the dependency injection system makes FastAPI compatible with all the relational databases, NoSQL databases, external packages, external APIs, authentication and authorization systems, API usage monitoring systems, response data injection systems, etc. Simple and powerful, although the hierarchical dependency injection system is very simple to define and use. It's still very powerful. You can define dependencies that in turn can define dependencies themselves. In the end, a hierarchical tree of dependencies is built, and the dependency injection system takes care of solving all these dependencies for you and their subdependencies, and providing injecting the results at each step. For example, let's say you have 4 API endpoints path operations. Items public items, private users userid activate items pro then, you could add different permission requirements for each of them just with dependencies and subdependencies. Integrated with OpenAPI all these dependencies, while declaring their requirements, also add parameters.
Although the hierarchical dependency injection is very simple and defined to estimate in the hierarchical dependency injection, this time takes care of solving the dependency in the subdependency by injecting the result points, path operations, items, public current is the active items public and then you can add different permission requirements.
Validations, etc. to your path operations. FastAPI will take care of adding it all to the OpenAPI schema, so that it is shown in the interactive documentation systems. Classes as dependencies. Before diving deeper into the dependency injection system, let's upgrade the previous example. A dict from the previous example. In the previous example, we were returning a dict from our dependency, dependable. But then we get a dict in the parameter commons of the path operation function. And we know that editors can't provide a lot of support like completion for dicts, because they can't know their keys and value types. We can do better. What makes a dependency? Up to now, you have seen dependencies declared as functions. But that's not the only way to declare dependencies, although it would probably be the more common. The key factor is that a dependency should be a callable. A callable in Python is anything that Python can call like a function. So, if you have an object, something that might not be a function, and you can call it, execute it like, or then it is a callable. Classes as dependencies. You might notice that to create an instance of a Python class, you use that same syntax. For example, in this case, Fluffy is an instance of the class cat. And to create Fluffy, you are calling cat. So a Python class is also a callable. Then in FastAPI, you could use a Python class as a dependency. What FastAPI actually checks is that it is a callable function, class, or anything else, and the parameters defined. If you pass a callable as a dependency in FastAPI, it will analyze the parameters for that callable and process them in the same way as the parameters for a path operation function, including subdependencies. That also applies to callables with no parameters at all, the same as it would be for path operation functions with no parameters. Then we can change the dependency, dependable common parameters from above to the class common query params. Pay attention to the init method used to create the instance of the class. It has the same parameters as our previous common parameters. Those parameters are what FastAPI will use to solve the dependency. In both cases, it will have an optional query parameter that is a str, a skip query parameter that is an int with a default of 0, a limit query parameter that is an int with a default of 100. In both cases, the data will be converted, validated, documented on the OpenAPI schema, etc. Use it now. You can declare your dependency using this class. FastAPI calls the common query params class. This creates an instance of that class, and the instance will be passed as the parameter commons to your function. Type annotation versus depends. Notice how we write common query params twice in the above code. Tab Python 3.8 plus tab Python 3.8 plus non-annotated tip. Prefer to use the annotated version if possible. The last common query params, in, is what FastAPI will actually use to know what is the dependency. It is from this one that FastAPI will extract the declared parameters, and that is what FastAPI will actually call. In this case, the first common query params, in, tab Python 3.8 plus tab Python 3.8 plus non-annotated tip. Prefer to use the annotated version if possible. Doesn't have any special meaning for FastAPI. FastAPI won't use it for data conversion, validation, etc., as it is using the depends common query params for that. You could actually write just tab Python 3.8 plus tab Python 3.8 plus non-annotated tip. Prefer to use the annotated version if possible. As in, but declaring the type is encouraged, as that way your editor will know what will be passed as the parameter commons, and then it can help you with code completion, type checks, etc. Shortcut, but you see that we are having some code repetition here, writing common query params twice. Tab Python 3.8 plus tab Python 3.8 plus non-annotated tip. Prefer to use the annotated version if possible. FastAPI provides a shortcut for these cases, in where the dependency is specifically a class that FastAPI will call to create an instance of the class itself. For those specific cases, you can do the following. Instead of writing tab Python 3.8 plus tab Python 3.8 plus non-annotated tip, prefer to use the annotated version if possible. You write tab Python 3.8 plus tab Python 3.8 non-annotated tip, prefer to use the annotated version if possible. You declare the dependency as the type of the parameter, and you use depends without any parameter, instead of having to write the full class again inside of depends common query params. The same example would then look like, and FastAPI will know what to do. Tip if that seems more confusing than helpful, disregard it, you don't need it. It is just a shortcut, because FastAPI cares about helping you minimize code repetition. Subdependencies, you can create dependencies that have subdependencies. They can be as deep as you need them to be. FastAPI will take care of solving them. First dependency, dependable, you could create a first dependency, dependable like, it declares an optional query parameter q as a SDR, and then it just returns it. This is quite simple, not very useful, but will help us focus on how the subdependencies work. Second dependency, dependable and dependent, then you can create another dependency function, a dependable, that at the same time declares a dependency of its own, so it is a dependent too. Let's focus on the parameters declared. Even though this function is a dependency, dependable itself, it also declares another dependency. It depends on something else. It depends on the query extractor and assigns the value returned by it to the parameter q. It also declares an optional last query cookie as a SDR. If the user didn't provide any query q, we use the last query used, which we saved to a cookie before. Use the dependency, then we can use the dependency with. Info, notice that we are only declaring one dependency in the path operation function, the query or cookie extractor. But FastAPI will know that it has to solve query extractor first, to pass the results of that to query or cookie extractor while calling it. Using the same dependency multiple times, if one of your dependencies is declared multiple times for the same path operation. For example, multiple dependencies have a common subdependency. FastAPI will know to call that subdependency only once per request. And it will save the returned value in a cache and pass it to all the dependents that need it in that specific request, instead of calling the dependency multiple times for the same request. In an advanced scenario, where you know you need the dependency to be called at every step, possibly multiple times in the same request, instead of using the cached value, you can set the parameter useCache equals false when using depends. Tab Python 3.8 plus tab Python 3.8 plus non-annotated tip, prefer to use the annotated version if possible. Recap: apart from all the fancy words used here, the dependency injection system is quite simple. Just functions that look the same as the path operation functions. But still, it is very powerful and allows you to declare arbitrarily deeply nested dependency, graphs, trees. Tip: all this might not seem as useful with these simple examples, but you will see how useful it is in the chapters about security, and you will also see the amounts of code it will save you. Dependencies in path operation decorators, in some cases, you don't really need the return value of a dependency inside your path operation function. Or the dependency doesn't return a value, but you still need it to be executed solved. For those cases, instead of declaring a path operation function parameter with depends, you can add a list of dependencies to the path operation decorator. Add dependencies to the path operation decorator. The path operation decorator receives an optional argument dependencies. It should be a list of depends. These dependencies will be executed solved the same way as normal dependencies, but their value if they return any won't be passed to your path operation function. Tip: some editors check for unused function parameters and show them them as errors. Using these dependencies in the path operation decorator, you can make sure they are executed while avoiding editor tooling errors. It might also help avoid confusion for new developers that see an unused parameter in your code and could think it's unnecessary. Info: in this example, we use invented custom headers xkey and xtoken. But in real cases, when implementing security, you would get more benefits from using the integrated security utilities the next chapter internal link target equals blank. Dependencies, errors, and return values, you can use the same dependency functions you use normally. Dependency requirements, they can declare request requirements like headers or other subdependencies. Raise exceptions, these dependencies can raise exceptions, the same as normal dependencies. Return values, and they can return values or not, the values won't be used. So, you can reuse a normal dependency that returns a value you already use somewhere else, and even though the value won't be used, the dependency will be executed. Dependencies for a group of path operations later, when reading about how to structure bigger applications. Multiple files internal link target equals blank, possibly with multiple files, you will learn how to declare a single dependencies parameter for a group of path operations. Global dependencies. Next, we will see how to add dependencies to the whole FastAPI application so that they apply to each path operation.
काय नको.
Global dependencies, for some types of applications, you might want to add dependencies to the whole application. Similar to the way you can add dependencies to the path operation decorator's internal link target equals blank, you can add them to the FastAPI application. In that case, they will be applied to all the path operations in the application. And all the ideas in the section about adding dependencies to the path operation decorator's internal link target equals blank still apply, but in this case, to all of the path operations in the app. Dependencies for groups of path operations later, when reading about how to structure bigger applications, multiple files internal link target equals blank, possibly with multiple files, you will learn how to declare a single dependencies parameter for a group of path operations. Dependencies with Yield FastAPI supports dependencies that do some extra steps after finishing. To do this, use Yield instead of return and write the extra steps code after. Tip: make sure to use Yield one single time per dependency. Note technical details: any function that is valid to use with, at contextlib, context manager, or at contextlib. A syncon text manager would be valid to use as a FastAPI dependency. In fact, FastAPI uses those two decorators internally. A database dependency with Yield, for example, you could use this to create a database session and close it after finishing. Only the code prior to and including the yield statement is executed before creating a response. The yielded value is what is injected into path operations and other dependencies. The code following the yield statement is executed after creating the response, but before sending it. Tip: you can use async or regular functions. FastAPI will do the right thing with each, the same as with normal dependencies. A dependency with yield and try: if you use a try block in a dependency with yield, you'll receive any exception that was thrown when using the dependency. For example, if some code at some point in the middle, in another dependency, or in a path operation, made a database transaction, rollback, or create any other error, you will receive the exception in your dependency. So, you can look for that specific exception inside the dependency with except some exception. In the same way, you can use finally to make sure the exit steps are executed, no matter if there was an exception or not. Subdependencies with yield, you can have subdependencies and trees of subdependencies of any size and shape, and any or all of them can use yield. FastAPI will make sure that the exit code in each dependency with yield is run in the correct order. For example, dependency can have a dependency on dependencib and dependencib on dependencia, and all of them can use yield. In this case, dependency, to execute its exit code, needs the value from dependencib here named dep to still be available. And, in turn, dependencib needs the value from dependencia here named depa to be available for its exit code. The same way, you could have some dependencies with yield and some other dependencies with return, and have some of those depend on some of the others. And you could have a single dependency that requires several other dependencies with yield, etc. You can have any combinations of dependencies that you want. FastAPI will make sure everything is run in the correct order. Note technical details, this works thanks to Python's context managers. FastAPI uses them internally to achieve this. Dependencies with yield and HTTP exception, you saw that you can use dependencies with yield and have try blocks that catch exceptions. The same way, you could raise an HTTP exception or similar in the exit code after the yield. This is a somewhat advanced technique, and in most of the cases you won't really need it, as you can raise exceptions including HTTP exception from inside of the rest of your application code, for example, in the path operation function. But it's there for you if you need it. An alternative you could use to catch exceptions and possibly also raise another HTTP exception is to create a custom exception handler internal link target equals blank. Dependencies with yield, and except if you catch an exception using except in a dependency with yield and you don't raise it again or raise a new exception. FastAPI won't be able to notice there was an exception, the same way that would happen with regular Python. In this case, the client will see an HTTP 500 internal server error response as it should, given that we are not raising an HTTP exception or similar, but the server will not have any logs or any other indication of what was the error. Face screaming in fear, always raise in dependencies with yield, and except if you catch an exception in a dependency with yield. Unless you are raising another HTTP exception or similar, you should re-raise the original exception. You can re-raise the same exception using raise. Now the client will get the same HTTP 500 internal server error response, but the server will have our custom internal error in the logs. Smiling face with sunglasses execution of dependencies with yield, the sequence of execution is more or less like this diagram. Time flows from top to bottom, and each column is one of the parts interacting or executing. executing code. Only one response will be sent to the client. It might be one of the error responses, or it will be the response from the path operation. After one of those responses is sent, no other response can be sent. This diagram shows HTTP exception, but you could also raise any other exception that you catch in a dependency with yield or with a custom exception handler internal link target equals blank. If you raise any exception, it will be passed to the dependencies with yield, including HTTP exception. In most cases, you will want to re-raise that same exception or a new one from the dependency with yield to make sure it's properly handled. Dependencies with yield, HTTP exception. Except and background tasks warning, you most probably don't need these technical details. You can skip this section and continue below. These details are useful mainly if you were using a version of FastAPI prior to 0.1060 and used resources from dependencies with yield in background tasks. And because the exit code would be executed, travel through the network, while unnecessarily holding a resource in a dependency with yield, for example, a database connection. This was changed in FastAPI 0.1060. Additionally, a background task is normally an independent set of logic that should be handled separately, with its own resources, e.g. its own database connection. So, this way you will probably have cleaner code. If you used to rely on this behavior, now you should create the resources for background tasks inside the background task itself, and use internally only data that doesn't depend on the resources of dependencies with yield. For example, instead of using the same database session, you would create a new database session inside of the background task, and you would obtain the objects from the database using this new session. And then, instead of passing the object from the database as a parameter to the background task function, you would pass the ID of that object and then obtain the object again inside the background task function. Context managers. What are context managers? Context managers are any of those Python objects that you can use in a with statement. For example, you can use with to read a file. Underneath the open sum file, txt creates an object that is called a context manager. When the with block finishes, it makes sure to close the file, even if there were exceptions. When you create a dependency with yield, FastAPI will internally create a context manager for it and combine it with some other related tools. Using context managers in dependencies with yield warning, this is, more or less, an advanced idea. If you're just starting with FastAPI, you might want to skip it for now. In Python, you can create context managers by creating a class with two methods, enter and exit. You can also use them inside of FastAPI dependencies with yield by using with or async with statements inside of the dependency function. Another way to create a context manager is with @contextlib, context manager, or @contextlib. Async context manager using them to decorate a function with a single yield. That's what FastAPI uses internally for dependencies with yield. But you don't have to use the decorators for FastAPI dependencies, and you shouldn't. FastAPI will do it for you internally. Security, there are many ways to handle security, authentication, and authorization. And it normally is a complex and difficult topic. In many frameworks and systems, just handling security and authentication takes a big amount of effort and code. In many cases, it can be 50% or more of all the code written. FastAPI provides several tools to help you deal with security easily, rapidly, in a standard way, without having to study and learn all the security specifications. But first, let's check some small concepts. In a hurry, if you don't care about any of these terms and you just need to add security with authentication based on username and password right now, skip to the next chapters. OAuth 2 is a specification that defines several ways to handle authentication and authorization. It is quite an extensive specification and covers several complex use cases. It includes ways to authenticate using a third party. That's what all the systems with login with Facebook, Google, Twitter, GitHub use underneath. OAuth 1, there was an OAuth 1, which is very different from OAuth 2 and more complex, as it included direct specifications on how to encrypt the communication. It is not very popular or used nowadays. OAuth 2 doesn't specify how to encrypt the communication. It expects you to have your application served with HTTPS. Tip: in the section about deployment, you will see how to set up HTTPS for free using Traffic and Let's Encrypt. OpenID Connect is another specification based on OAuth 2. It just extends OAuth 2, specifying some things that are relatively ambiguous in OAuth 2 to try to make it more interoperable. For example, Google Login uses OpenID Connect, which underneath uses OAuth 2. But Facebook Login doesn't support OpenID Connect. It has its own flavor of OAuth 2. OpenID, not OpenID Connect, there was also an OpenID specification. That tried to solve the same thing as OpenID Connect, but was not based on OAuth 2. So, it was a complete additional system. It is not very popular or used nowadays. OpenAPI, previously known as Swagger, is the open specification for building APIs, now part of the Linux Foundation. FastAPI is based on OpenAPI. That's what makes it possible to have multiple automatic interactive documentation interfaces, code generation, etc. OpenAPI has a way to define multiple security schemes. By using them, you can take advantage of all these standard-based tools, including these interactive documentation systems. OpenAPI defines the following security schemes: API key, an application-specific key that can come from a query parameter, a header, a cookie. HTTP, standard HTTP authentication systems, including bearer, a header authorization with a value of bearer plus a token. This is inherited from OAuth 2. HTTP basic authentication, HTTP digest, etc. OAuth 2, all the OAuth 2 ways to handle security called flows. Several of these flows are appropriate for building an OAuth 2 authentication provider like Google, Facebook, Twitter, GitHub, etc. Implicit client credentials authorization code, but there is one specific flow that can be perfectly used for handling authentication in the same application directly. Password. Some next chapters will cover examples of this. OpenID Connect has a way to define how to discover OAuth 2 authentication data automatically. This automatic discovery is what is defined in the OpenID Connect specification. Tip: integrating other authentication authorization providers like Google, Facebook, Twitter, GitHub, etc. is also possible and relatively easy. The most complex problem is building an authentication authorization provider like those, but FastAPI gives you the tools to do it easily while doing the heavy lifting for you. FastAPI Utilities. FastAPI provides several tools for each of these security schemes in the FastAPI. security module that simplify using these security mechanisms. In the next chapters, you will see how to add security to your API using those tools provided by FastAPI. And you will also see how it gets automatically integrated into the interactive documentation system.
काय 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 बोल काय ना जाय जाऊन येऊ काय कुठं हां